What's up? Are you ready to do some graphing matching? Oh my gosh. All right, so we've got some graphs, we've got some equations, we gotta work, find some zeros, check our end behavior, things like that. That's what we're looking for here. So I'm actually gonna have us look at the graphs first. If you look at graph A, is that an even or odd degree? Well, remember, even degrees start and end in the same way. So they're either both going up or both going down, which I see these are both heading down. So that would indicate that it is an even degree polynomial, but typically positive ones start heading upward. These are both heading downward, which means the lead coefficient would be negative. And if you look, the end behavior, as x approaches positive infinity, as it goes to the right, what happens to the y's? Well, the y's go down forever. So the y's approach negative infinity. And as the x's approach negative infinity to the left, the y's also go down towards negative infinity. Sweet. All right. We'll have to match that up with an equation in a little bit. Let's look at B. Well, B, I see that they are starting up top and ending up top, which again, if they start and end in the same direction, that means it is an even degree polynomial. Now, these are both going up, which means the lead coefficient would be positive. And again, they're both heading upward forever. So whether you go to the left or to the right, the y's are going to go towards positive infinity on both of these. Fun. Okay. Oh gosh. Graph C. Now I see it starts low, it ends high, so that would indicate that it is an odd degree, right? Because they start and end in different locations. Now, positive ones, when they're odd, start at the bottom at negative infinity and they go towards positive infinity, which this does that. So it's not reflected, which means its lead coefficient is positive. End behavior, as x approaches positive infinity, as this goes to the right, the y's go towards positive infinity. As this approaches negative infinity to the left, the y's approach negative infinity as well. All right, so this is what we started with last class. We started talking about this end behavior. And then graph D, is this even or odd? Well, I see it starts low and it ends high. They go in two different directions, which means it is an odd polynomial. That is pretty odd. All right. Positive lead coefficient, because it starts at the bottom, it ends at the top, right? So that's positive. Looks like I'm a magician. It just shows up afterwards. And then end behavior, as x approaches positive infinity to the right, y approaches positive infinity. And as x approaches negative infinity to the left, the y approaches negative infinity because it starts going down from there. Now, graphs E and F are blank because not all the questions we have are going to have matching graphs. So for those, we're going to have to draw them. So we'll get there when we get there. Let's go to number 1 now on the equations. There we go. All right. Wow, that's a lot of stuff. Now, thank goodness, all we have to do is solve for the x-intercepts here. We don't have to multiply this out. Now, you'll see at the top here, I have the chart. It's just kind of shrunk down, and I wanted the equation to be large. So we'll get all this information here, but it might not be in its column because I can't write that small up on the smartboard. So if we're looking for the x-intercepts, here it says x plus 1, which means that x-intercept would be -1. Now you'll see that this one is squared, which means it has a multiplicity of 2. Now remember, when that shows up on the graph, when it has an even multiplicity, that means it hits that 0 and then starts heading the other direction. So we'll see it hit -1 and then turn back around. Now this one would hit at positive 1. If it says x minus 1, think we're solving the equation x minus 1 equals 0. So we add 1 to the other side. That's how we get the positive 1. And then over here, x minus 4, that means x will equal positive 4. Wow, it's the end of the day, so everything's going a little slower, I guess. So I'll dance while it's still boxing up there. All right, and we're good. All right, so the degree, if you look, this has a multiplicity of 2, so that would be the second degree. Here's another 0, so that would be the third degree, and then another 0 would be the fourth degree. So we'll say fourth degree, and that means it's an even function. Now remember, even functions start and end in the same direction. Now it says the lead coefficient. Really, we just need to state if that would be a positive or a negative number. If we multiplied all these out, this would come out to just x to the fourth over here, and then we would multiply that by 5/6 at the end. So it would be 5/6 as the lead coefficient. It wouldn't be reflective. So we would say that the lead coefficient is positive. Now the end behavior, if it is even and positive, that means they start high and they end high. So as x approaches positive infinity, wow, this is really, as x approaches positive infinity, that means y would also approach positive infinity. And as x approaches negative infinity, y still approaches positive infinity. So as x approaches negative infinity, y still approaches positive infinity. So we're looking for a graph where it hits -1 and turns around. It's going to cross through 1, positive 1, and it's also going to cross through 4. So if you look at all the graphs, that one matches up with graph B. If you look, here it hits -1, starts turning around, it crosses again at +1 and +4. It's a positive lead coefficient, and it's even because they start and end heading upward. So the graph for number 1 is B. Let's see what we got for number 2. Oh, we're going to have to factor this one. I see it's x to the fourth. So instead of it just being x squared, where we would say like x minus and x minus, this one would just be x squared minus and x squared minus. What factors of 1 add up to 2? 1 and 1. Now, those are both the same, but those are also a difference of squares. So I'm going to write it as a difference of squares. So x squared minus 1 would factor to x plus 1 times x minus 1. So would this one, another x plus 1, x minus 1. Now if we clean that up and make it adorable, we have 2 of those x plus 1s, so we'll say x plus 1 squared, and we have 2 x minus 1s, so x minus 1 squared. Which means as far as finding our zeros, our x-intercepts, this one over here, x plus 1, our x-intercept, our 0, would be -1. And that one is squared, which means it has a multiplicity of 2. Over here, very similar, this one says x minus 1. So that means x equals +1, and this also has a multiplicity of 2. So again, when it has that even multiplicity, that means it hits it and turns around and heads the other direction. The degree, well, it was the fourth degree, which is even. And remember, even ones start and end in the same direction, either both up or both down. If the lead coefficient is positive, which it is here, it's +1, that means it's going to start high and end high. So as far as the end behavior, as x approaches positive infinity, and as x approaches negative infinity. We just said that it's going to start high and end high. So both of them are going to be y approaching positive infinity. we're looking for a graph that hits -1 and +1, doesn't cross through, turns around at that point. It's even and positive, which means it's going to look like a W. It's going to hit 1 and -1. The graph that does that is graph E. What? Look, it doesn't match up with any of the graphs that we have here. So we're going to have to do this one ourselves. So let me scooch this up a bit. Oh, it looks like I threw it way up there. It's going to cross at -1 and +1. Here's -1, here's +1. You could also say, if you look at the original problem, this +1 at the end is like our y-intercept. So it's technically going to cross at +1 as well. It's even and it's positive, which means it's going to look kind of like a W in this case. So it's going to start from the top, it's going to hit -1, and then it will start changing directions, going back up, and it'll hit +1 and kind of do the same thing. So that's about as good as I can get it. Now let's pretend like I actually hit that x-axis there. So even or odd, even. Positive or negative, positive. We already did this stuff on here. And then end behavior, both of them, y is going to be approaching positive infinity. Great, all right, okay. 2 down, here we go. Oh boy, wow, I have 4 terms. We could do some synthetic division to find a 0. Let's see if we can factor this one by grouping. That's easier for me. So the left 2 terms have an x² in common, which when we factor out x², it leaves us with x plus 1. On the right side, 4x and 4 have a 4 in common. 4 times x is 4x, 4 times 1 is 4. Hey, they both have x plus 1 in the parenthesis. So that would go into part of our factoring. So outside we factored out x² plus 4. Over here we have the x plus 1 in common, so that would go in the other set of parentheses. Now here I would tell you to look for if you have a difference of squares. Here we have a sum of squares, which we can't factor that. So if we look here, this is all we can factor. We'll find the zeros in a second, but look at the other questions. The degree, look at the original question. It was to the 3rd degree, which means it's odd. But when you have an odd degree, remember they start and end in opposite directions. The lead coefficient was +1. So when it's positive and it's an odd degree, that means it starts low and ends high. So as x approaches positive infinity, so does y. As x approaches negative infinity, so does y. So we'll do that. X approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity. The only thing we haven't done is solve for the x-intercepts. I see this x plus 1, which means x equals -1. And it has a multiplicity of 1, which just means it's just going to cross through at -1. Now here we'd have to solve the equation x² plus 4 equals 0. We're going to have to subtract the 4, which will give us x² equals -4. And then we have to square root both sides. When you square root a negative, that's where we use those complex numbers, the I. So the square root of regular 4 is 2. So this would just be plus or minus 2i. Now, if you're using imaginary numbers, that's not actually going to cross the x-intercept at that point. But it will cross at -1. So even though we have 3 zeros, really one of them will be on the x-axis. So we're looking for odd. 3rd degree, it's positive, so it's need to start low, end high, and we're looking for one that crosses at -1. So it's got to hit -1 on the x-axis. A graph that does that? Oh, it's graph C. Oh my gosh, incredible. It's so much fun that Grant's here.
Did I leave my AirPods in here?
Oh no!
Yep.
Oh my gosh, I was about to sell them on eBay. Oh my, you're here too? Oh, Miss Parker grabbed your book.
Okay.
And she said she would get it to you tomorrow, first period.
Okay. Thank you.
All right, you're welcome. Well, I wonder if I'll be able to cut those out. Well, maybe. All right, maybe we're back. Maybe we've cut here and we're back. I don't know. Oh, the joys, the joys. All right, number 4, we've got x cubed minus 5x. Now, we can solve for those in a second, but let's get some of the stuff that we know. We know it's to the 3rd degree, which means it's odd. Its lead coefficient is positive 1. So if it's to the 3rd, if it's an odd and it's positive, that means it starts low and ends high. So end behavior as x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y approaches negative infinity.
X approaches positive infinity, y approaches positive infinity. X approaches negative infinity, y approaches negative infinity.
Great! I bet we can figure out what graph it is just from that, but we're too cool for that. Let's also find the zeros. Greatest common factor, these have an x in common. If we factor out an x, that would leave us with x squared minus 5. So, on the outside, if you just have an x out there, or if it was 6x or whatever, if it's on the outside, that means you're going to have 0 as a 0. And it was just to the 1st power, so it doesn't have that multiplicity. In here, we're going to have to solve an equation. X squared minus 5 equals 0. We'll add the 5, and then we're going to square root it. Now we're square rooting a positive number, so it'll work out. I think it came out to like 2.2, 2.3, something like that. Let's say 2.3-ish. So that means we're looking for a graph where it crosses at 0, negative 2.3-ish, and positive 2.3-ish. It's odd with a positive lead coefficient. So it's going to look like this, but it has to cross at those 3 places. Negative 2.3, 0, and positive 2.3. Now if we look at our graphs, that matches up with graph D. Oh my gosh, there's about negative 2.3-ish, there's 0, there's positive 2.3-ish. That was fun. That was fun, and you know it. Don't say it wasn't. All right. We're already on number 5. Oh my gosh. Let's get the stuff we know. The degree, it's the 4th degree. It's even. The lead coefficient is negative. Oh my gosh, is this the first time we've had that? Now, if it's even, they start and end in the same place, but the lead coefficient is negative. So they're both gonna head towards negative infinity. So end behavior, as x approaches positive infinity, y goes towards negative infinity. As x approaches negative infinity, y approaches negative infinity. Remember, even functions, the y's are going to be going in the same direction. If it's positive lead coefficient, they're both going towards positive infinity. This one was negative, so they're both going towards negative infinity. Now we got to actually solve this to find the zeros. Factor it, solve it. We'll factor out our negative 2 first, which would leave us with x to the 4th minus 2x squared plus 1. Factors of 1 that add up to 2 would be 1 and 1. They would have to both be minus here. So we have x squared minus 1 and another x squared minus 1. Now we could say that's x squared minus 1 squared, but we also have a difference of squares. So I'm going to suggest we write it as difference of squares first. X squared minus 1 would factor to x plus 1 times x minus 1. So would this other x squared minus 1. X plus 1 times x minus 1. Now if we were to clean it up, I have 2 of these x plus 1s. So I'm going to say x plus 1 squared. I have 2 of these x minus 1s. So I'm going to say x minus 1 squared. So when we're finding our zeros, over here, x plus 1, that means our 0 would be negative 1. And this one was squared, so it has a multiplicity of 2. This one is x minus 1, which means our x would be positive 1. So this would also have a multiplicity of 2. So it's going to hit negative 1 and positive 1. It's also going to start and end at the low ends. So it's going to be like an upside down W type thing. But it's got to just hit negative 1, turn around, hit positive 1, and turn around. That matches up with graph A. Look at that. It's an upside down W. It hits negative 1, and it hits positive 1. Great! Now, you'll notice that number 6 doesn't have any graphs that match up with it left. We already used graph A, B, C, and D. We filled out graph E. So we're going to have to graph this one ourselves. But let's figure out the important stuff here. Oh, goodness me, oh my. We still got to factor this stuff? But if you look, there's x to the second here and x to the second there. So there's 2 zeros over here, there's 2 zeros over here, which means there's going to be 4 zeros altogether. So this is going to be the 4th degree, which is even. Our lead coefficient, after we multiply all this stuff out, it's going to come out to positive 4x to the 4th. And then we'd multiply that by positive 1/15. So all of it would come out positive. So it's even and it's positive, which means it starts high and it ends high. So as far as end behavior, as x approaches positive infinity and as x approaches negative infinity, either way, it's going upward. So y is going to approach positive infinity. All right, now we still need to factor this out. So I'm going to switch colors. So let's go with black. So if we could factor this, we have a difference of squares. The square root of 4x squared is 2x. The square root of 9 is 3. So this would give us 2x plus 3 times 2x minus 3. Over here, we need numbers that multiply to negative 12 and add up to negative 1. If they multiply to negative 12, you know it's got to be a positive times a negative. Factors of 12 that are 1 apart would be 4 and 3. So to make them add up to negative 1, it'd have to be negative 4 and positive 3. There it is. Everything is factored. Now, to solve these, we're solving 2x plus 3 equals 0. We're solving 2x minus 3 equals 0. We're solving x plus 3 equals 0, but we would just subtract the 3. So I'm not going to write that one. I'm just going to say x equals negative 3. Same thing here. It says x minus 4 equals 0, so you would add the 4, and x equals 4. So those two are easy, but these two are two-step equations that we have left. So for 2x plus 3, we'd have to subtract the 3. 2x equals negative 3. And then we would divide by 2. So we'll get x equals negative 3 over 2, which is like negative 1.5. On 2x minus 3 equals 0, we would add the 3 first. So 2x equals 3. Then we would divide by 2. So we'd get x equals positive 3 over 2, or positive 1.5. So let's get this going on our graph. Look at this. I'm just taking us on a journey here. Well, we'll see when it stops. This video is quite an adventure, if anyone's even watching it. Oh gosh. All right, so we know it's even. We know it's positive coefficient. So again, if you look at this W on the right, that's the shape it's going to take. But it's going to cross at negative 1.5, positive 1.5, negative 3, and positive 4. So I got to make sure I include negative 3 and positive 4. 1, 2, 3. 1, 2, 3, 4. So we've got the negative 3. We've got the positive 4. We've also got this negative 1.5, that'd be about there. And we've got positive 1.5, would be about there. So we just need to make sure our line kind of goes through those points. They all have a multiplicity of 1. So it starts up high. It's going to cruise down through negative 3, up through negative 1.5, back down through 1.5, and back up through 4. So this is an even polynomial with a positive lead coefficient, and both, whichever direction you go, the y's are going towards positive infinity for the end behavior. That's it, man. We did it. We did it. We're done.